We now move on to how to explain a p-value in the context of a problem. We look at the first example. In this example, suppose a researcher is testing the hypothesis that the null hypothesis is stating that the population proportion is 0.30 and the alternative is that the population proportion is greater than 0.30, and she finds the p-value to be 0.31. Explain what this means. That'll be the first step. And then we are to check if she would reject the null hypothesis and why. That'll be the second thing we would like to talk about. So I'm going to split this space into two. One to explain what it means, and then the other to see if she will reject the null hypothesis. To begin with, the p-value of 0.31 means the following. First of all, note that 0.31 translates to 31 out of 100. So, what a p-value of 0.31 means is that 31 in 100 samples will give a sample proportion as high or higher than the one obtained in the sample data as long or provided or under the assumption that the population proportion is really 0.30 rather 0.30 in this example based on the null hypothesis. That is what the p-value means. Then in this case, would she reject the null hypothesis? Why? The p-value is 0.31. This is a very, very high probability. In fact, whether you set your alpha to 0.1, that is 1%, 0.05, or even 0.1, which is 10%, this p-value is greater than all of these possible or many of these, all of these common alphas. So if the p-value is greater than alpha, remember, in the last example, whenever your p-value is greater than alpha, it means it is large enough that we should reject the null hypothesis. So I would argue that this p-value is very large, is large. So this is very large. And most times it is larger than what? Alpha. So I will do not reject the null hypothesis because the p-value is very large. Another example. Some have argued that throwing data at the stock pages to decide which companies to invest in could be a successful stock picking strategy. Suppose a researcher decides to test this theory and randomly samples or chooses 250 companies to invest in. After 1 year, 135 of the companies were considered winners. That is, they outperformed other companies in the same investment class. To assess whether the data picking strategy resulted in a majority of winners, the researcher tested the null hypothesis that the proportion is 0.5 versus the alternative that it is greater than 0.5 and obtained a p-value of 0.1030. Explain what this p-value means and write a conclusion for the researcher. Assume alpha is 0.1 or less. So in this case, the meaning of the p-value will be as follows. What the p-value means is that if the population proportion is really 0.5, as assumed in the null hypothesis, then this 0.1030 means that about 10 in 100 samples will give a sample proportion as high or higher than the one obtained. Take note that 0.1030 approximately to 2 decimal places is 0.10, which is equivalent to 10 out of 100. This is where I got the 10 in 100 samples from. Then, we are to write a conclusion based on the assumption that alpha is 0.1 or less. Well, what we observe is that our p-value is 0.1030, which is greater than alpha. Whenever our p-value is greater than alpha, what do? We always do not reject the null hypothesis. So in this case, our conclusion would be do not reject the null hypothesis. And if we are not rejecting the null hypothesis, it means we have insufficient evidence for the hypothesis we want to test. So we have insufficient evidence for the hypothesis, the alternative hypothesis that we want to test. So it is a good time to note what hypothesis testing, which is otherwise called a test of statistical significance, means. A statistical significance means that the result that we obtain from a sample is so unusual that the null hypothesis, that under the assumption that the null hypothesis is assumed to be true. That is, if the null hypothesis is assumed to be true, when we get statistical significance in our sample data is if the results from that sample data is so unusual that we have to go back to the null hypothesis and say, even though we assumed you to be true, under your assumption, we're getting an unusual result, so unfortunately, we have to what? Reject you. And that would lead to enough evidence in support of the alternative hypothesis. So with that said, we proceed to putting it all together. And that is conducting a hypothesis test for a population proportion. How do we do this? We take the first example. In this example, we're going to go through all the steps. So we're going to test the hypothesis using the p-value approach, and we'll be sure to verify the requirements of the test. To begin with, we first make sure we verify the requirements of the test. So what are the requirements? So the requirements are as follows. The first one is to check if NP0 times 1 minus NP0 is at least 10. What is our P0 in this case? That is the hypothesized value of the proportion, which is 0.50. So my N is 100, the sample size, times 0.5 times 1 minus 0.5. What is my answer? I got 25. This is definitely greater than 10, so the first requirement is met. The second requirement is that I should check if the sample size is at least 5% of the entire population. In this case, I don't have the entire population, so I'm going to assume that the sample size meets this condition. Then, in the third condition, is that the sample must be a random sample. So in this case again, the only way I can go about this test is to assume that this assumption or requirement is met before I am asked to test the hypothesis using the p-value approach. So with that said, the next step would be to write my null hypothesis, my alternative hypothesis. This is 0.50 and this is greater than 0.50. Okay, then the next step would be to find the test statistic and to find the p-value. So how am I going to do that? In order to find my test statistic and the p-value, I will go to StatCrunch. In StatCrunch, go to Statistics. This hypothesis is about proportion statistics. So I'll go to one sample and with summary. I'm going to with summary because I don't have raw data. So with summary, and in number of successes, going back, my X is 60 out of 100. So I will put the 60 out of 100, and I will indicate that I want to perform a hypothesis test. By default, it goes to p equals 0.5, which matches exactly what I have in my null hypothesis, but my alternative should be strictly greater. So I'll go back and change this inequality to greater. I want greater than 0.5 and compute. And from here, let's see. So I am going to increase this. I have my test statistic, which is 2, and I also have my p-value. So I'll take that to my working board. So I have the test statistic of 2 and a p-value of 0.0228. Now, the question tells me to use the p-value approach, and I'm given alpha to be 0.05. So this is a good time to remember my decision rule, the decision rule we mentioned earlier when it comes to using the p-value and alpha. It is that if the p-value is less than alpha, I should reject the null hypothesis. Otherwise, if the p-value is greater than alpha, I should not reject the null hypothesis. So let's see. Based on this decision rule, I will look for at my p-value, which is 0.0228. Now look my alpha, I'll look at my alpha, which is 0.05. I'll compare them. 0 to 0, 0 to 0. 2 is lesser than 5. So in this case, this is the case of p-value, which is lesser than alpha. So this would cause me to reject the null hypothesis. So I'm ready to draw my conclusions now. And here I am going to reject the null hypothesis. And if I'm rejecting the null hypothesis, it means I have sufficient evidence in support of my alternative hypothesis. So we can say, thus, we have sufficient evidence in support of the hypothesis we wanted to test, namely the alternative hypothesis, which claims that the proportion exceeds 0.50. With that said, we have completed that question. So we go on to yet the next example. 20 years ago, 54% of parents of children in high school felt it was a serious problem that high school students were not being taught enough math and science. A recent survey found that 331 of 900 patients of children, let me read that again. A recent survey found that 331 of 900 parents of children in high school felt it was a serious problem that high school students were not being taught enough math and science. Do parents feel differently today than they did 20 years ago? Use alpha equals 0.01 level of significance. Notice that in this example, there is no mandate or requirement that we have to use a particular approach, unlike the previous example where we were mandated to use the p-value approach. So I'm going to take the liberty to illustrate the use of the test statistic versus the critical value approach. So let us begin. I'm going to split my page into 2 just in case I need to manage my space. And to begin with, I need to set up my null and alternative hypothesis. Well, we were told that back in the day, 20 years ago, 54% of parents of children in high school felt it was a serious problem that high school students were not being taught enough math and science. So this is about percentages, proportion, PP. Then what we want to test here is if parents feel differently today than they did 20 years ago. Feeling different means we want to test if this percentage is now different from 54%. Different from 54%, I can write 54% as 0.54. So in this case, the null hypothesis will be P equals 0.54, the opposite. And I am conducting this test at alpha equals 0.01 level of significance. What this means, take note, is that if we're conducting this test at alpha equals 0.01 level of significance, the confidence level of this test, is 1 minus alpha, that will be 1 minus 0.01 or 0.99 or 99%. Okay? And then the next thing is to find. I always, as a matter of preference, prefer finding the critical value first. Although when you're solving this in MyStatLab, it will require you to get the test statistic first. But as a matter of practice, I like to find my critical value first, and I'll tell you why. Because when I draw the picture, it is easy to bring this 99% into the picture. So I'm going to draw two band lines, and I'm going to shade this, and I'm going to indicate that this 99%, 0.99, leaves is the size of this shaded area. Then I will follow up with, I need the critical values here. One is negative, the other one is positive. How do I find it? I am going to need my Z, or normal distribution calculator. So use your normal calculator, and I will go to StatCrunch. I will close this and go to my calculators, go to the normal calculator, and under the normal calculator, I'm going to go ahead and drag this. All I need to change is, first of all, I need to change between. I want to change the interface. So make sure you click on between first, and then change this to 0.99. If this is 0.99, where did the 0.99 come from? Back to the question. That is your 99% confidence interval. And in this case, what you want is to compute this. This gives you the negative and the positive values for your critical value. Here they are. So here on your screen, I have those values here. So my critical value in summarized notation is written as plus or minus 2.5758. When you're working on this problem in MyStatLab, that is what it is. So here's the picture. The next step would be to find the test statistic, the value of the test statistic. To do that, you're going to need the value of x, you're going to need the value of n, the sample size. Going back to the question, you observe that they collected data from a sample, and that sample was highlighted here, a recent survey. We're told that x equals 331 out of a sample size of 900 parents rather. So this is 331 and this is 900. I can use StatCrunch to find the test statistic. So I'm going to close this and I'm going to go to StatCrunch for population stats, one sample with summary. And I want 331 out of 900. And in this case, for 331 out of 900, our hypothesized proportion value is 0.54. So I would make sure I specify that here, 0.54, and this will update automatically. Then make sure to check the inequality. The inequality here is not equal to, and that is a default one, so I don't need to change that. Hit compute. And from compute, I have my Z-stat calculator here. So my test statistic is negative 10.36656, right here, Z-stat. So right now on your screen, you can see that I currently have my test statistic. So what am I going to do with this test statistic? I need to check where it falls. Remember, all regions to the right and to the left in this case, this would be my rejection region and my other rejection region. Why? Because this is a two-tailed test, as you might recall. So, where does negative 10.36665 fall? You observe that it falls somewhere on the extreme here, which is in the rejection region, negative 10.36656. So since it falls in the rejection region, this would make me reject the null hypothesis. So since negative 10.36656 falls in the rejection region, as said earlier, we're going to reject the null hypothesis, which means this is the bad guy, and we have enough evidence or sufficient evidence in support of the hypothesis, the alternative hypothesis that we wanted to test. So we conclude that there is sufficient evidence in favor of the alternative hypothesis, which means that the parents now feel differently than they did 20 years ago. Now that we have completed that question, we proceed to the next example. In this example, we're told that in a survey, 45% of respondents stated that they talk to their pets on the telephone. A veterinarian believed this result to be too high. So that is someone making a claim. So he randomly selected 170 pet owners and discovered that 75 of them spoke to their pet on the telephone. Does the veterinarian have a right to be skeptical? Use alpha equals 0.05 level of significance. So as we did in the previous example, step 1, I am going to set up my null and alternative hypothesis. That'll be the first step. So to set up my alternative hypothesis, I will check if there is a claim. Initially, it was said that 45% stated that they talk to their pets on the telephone, but the veterinarian is claiming that he believes the result is too high. So what does that mean? Does he think it is lesser than 45%? I believe that to be so. So this would be a claim by this veterinarian claiming that this proportion should actually be lesser than what was claimed, 0.45. That would be the way to set your alternative hypothesis, and the null hypothesis will be 0p equals 0.45. Then once that is done, the second step, the way I explained it to you, is to find your critical value or values. Well, in this case, what you should note is how many tails do we have here? I can see that we only have a single left tail. So I'm going to draw this, and I'm going to indicate that I only have a left tail. Then if I have only a left tail, I need to find the critical value here. How do I find the critical value? Here's something to note. I need my alpha. My alpha is the size of this rejection region. And if it is 0.05, the confidence level, let me write this here, it means that the confidence level at which we are carrying out this test is 1 minus alpha, 1 minus 0.05, or 0.95, which is 95%. This 0.95 will take up all of the remaining space. So I have 0.95 here. So to find the critical value, I'll go to my normal distribution calculator. So go to Stats, Calculators, go to the normal calculator, and this time I don't want between. I don't want between because this region is only to the left. So I just want, in this case, the standard case, and I want to the left. And the size to the left, I want it to be 0.05. And compute. So take note. Why do I have one to the left? Because that is based on the fact that this is a left tailed test, and the size to the left is 0.05, my alpha. So as it stands, I have my critical value here, which is negative 1.645. So I'll take that back. This is negative 1.645 here. This is the only critical value here. So I should have only one value in this case. Unlike the previous example, where you have a two-tailed test. It could be greater, it could be lesser. So you have both regions here. So back to what we are working on. We have the critical value down. For 3, step 3, I need to find my test statistic. For my test statistic, I need the value of x and I need the value of n. N is the total sample size. In this case, the veterinarian selected 170 in total, and out of that 170, found 75 of them. So x is 75, n is 170. So 75 out of 170. And to find my test statistic, my z stat, this would be equal to, going back to StatCrunch, I'll go to stats, proportion stats, one sample with summary, and I want in particular my x is 75 out of 170. So I will have 75 out of 170, 75 out of 170 based on the results I have. And then I want to perform a hypothesis test to ensure that this is selected. What is the hypothesized proportion in the question? I'll go to my null and alternative hypothesis, 0.45. So I'll adjust this to 0.45, and this should update automatically. Then I'll be careful with this. What is this supposed to be? This is supposed to be less than, based on what we observe in the alternative. Please note that if that is incorrectly selected, you'll get the wrong answer and draw the wrong conclusions. So you have less than here, and then compute. So my z stat is negative 0.2312. So now at this point, I have my z statistic. I need to now trace this guy back to my graph. Where does it fall? Does it fall in the rejection region, which is after or to the left of negative 1.645, or to the right? Well, this is negative 1, negative 0.2312 should come before negative 1.645, going from right to left. So as it stands, we see that this does not fall in the rejection region. So let's make a comment about that. For negative 0.2312 does not fall in the rejection region. What does that mean? We're ready to draw a conclusion in this case. And our conclusion will be that since negative 0.2312 does not fall in the rejection region, that means we are also not going to reject the null hypothesis. If we are not rejecting it, it means this is the winner. Unfortunately, we do not have enough evidence for the alternative hypothesis that we want to test. So this means that we do not have sufficient evidence for the alternative hypothesis that we wanted to test. And in the context of this problem, this means that the veterinarian does not have a right to be skeptical, or does not have a right to start thinking that the percentage is actually too high. With that said, we now proceed to the next example. According to a certain government agency for a large country, the proportion of fatal traffic accidents in the country in which the driver had a positive blood alcohol concentration is 0.37. Suppose a random sample of 109 traffic fatalities in a certain region results in 53 that involved a positive BAC. Does the sample evidence suggest that the region has a higher proportion of traffic accidents or traffic fatalities involving a positive BAC than the country at alpha equals 1% level of significance? In order to begin this question, I'm going to split the screen up. And in particular, I'm going to start off with the first step, setting up the null and the alternative hypothesis. So in this case, what is my alternative? Does the sample evidence suggest that the region has a higher proportion? That would be higher than 0.37. So proportion higher than 0.37. That is what we want to test. And that will be against the null hypothesis that P is equal to 0.37. In order to conduct this test, just something to remember in between, that there are requirements which was illustrated in a previous example. We usually check if n times p naught times 1 minus p naught is greater than 10. We must check if n, the sample size, is lesser than or equal to 0.5 n. And then 3, if the sample taken, if the sample is random. Remember that your p naught in this case is 0.37, the hypothesized value of the proportion. In this case, all of these conditions are all satisfied. Some are assumed to be satisfied and some are calculated to be satisfied. So we continue to the next step. In this step, which is step 2, we need to find the critical value. And why do I have one value here? This is a one-tailed right-tailed test. So I'm going to draw the distribution. And this right tail tells me I should put this on the right. So I have the right tail there. And I need my critical value here. How do I find my critical value? I need my alpha. The size of the rejection region, alpha, is 1%. This is my rejection region. And in the other region, the remaining region, I have the remaining 99%, which is 0.99. So I can take this to StatCrunch quickly, go to calculators, go to the normal calculator, and indicate that I want the standard, and I can choose whichever one I want. I can put 0.99 to the left of the critical value. So I can do that too. So make sure that this is to the left, the arrowhead, and the size to the left is 0.99, and compute that. This is 2.326. So the value here is 2.326. That separates the rejection region from the acceptance region. Right. So with that said, I can proceed to step 3, which is to find my test statistic. To find my test statistic, I need X, I need N, and I'll plug them into StatCrunch to help me to get the Z stat. So what is my X in this case? I was told that a random sample of 109 traffic accidents were taken, and out of it, X equals 53 has the attribute of interest. So this is 53, and this is 109. Taking that to StatCrunch, I can go to StatCrunch and go to proportion stats, one sample with data. And in this case, this would be time to key in my 53 out of 109. So I go here, 53 out of 109. And the hypothesized value of the proportion is 0.37, and this must be greater than. So let me make those adjustments. This is 0.37, and I want greater than, and compute. So computing this, I have my Z-stat is 2.5135. So I'm going to take my z-stat to my working table. So here on the screen, I have my z test statistic, which is 2.5136. Now I'm going to trace where that falls. That definitely is bigger than 2.326. So it will lie to the right of 2.326, which means it is now in the rejection region. If it is in the rejection region, well, as we already know, this means we're going to reject the null hypothesis. So since 2.5136 falls in the rejection region, this would cause us to reject the null hypothesis and conclude that since we are rejecting the null hypothesis, we have enough evidence in support of the alternative, which claims that the proportion is actually greater than 0.37. And that means that there is sufficient evidence in the sample data to indicate that this region has a higher population of traffic fatalities involving a positive BAC than the country with a value of 0.37. So this brings us to the conclusion of hypothesis testing regarding a population proportion.